but it is brand new. So let's look at the notes I gave you yesterday. And basically, Mr. Passwater does a lot of like explaining stuff there. But basically, here's what's going on. All your life up to this point, when you have found an ordered pair, like 2, 3, you have plotted it on what we call the rectangular coordinate system, the Cartesian coordinate plane. And the reason it's called rectangular is because to plot that point, you count right or left and up or down. Your graph paper consists of a bunch of squares, doesn't it? Little rectangles, called a rectangular system. There is only one name for that point in the rectangular coordinate system. That point is 2, 3, period. There's no other name for it. Today, we're going to graph in a circular system. So instead of having a series of vertical and horizontal lines, we're going to have a series of circles. Okay? And we're going to plot points on our coordinate, on our rectangular, polar system. These are polar coordinates. On our polar system, we're going to plot points not as an X and a Y, that's rectangular, but as an R and a theta. And what R is going to stand for is the distance from the pole. In polar coordinates, that's called the pole. In rectangular coordinates, that's called the origin. Simple. So R is the distance from the pole. So like here, I'm 1 unit out from the pole. Here, I'm 2 units out. You can think of R as like a radius of that circle. And then theta is the angle in standard position. So for example, I didn't do this very well, but this might be, how are those things labeled? This would be pi over 12. This is pi over 6. This is pi over 4. This is pi over 3, and this is 5 pi over 12. I think our graph paper is in 12s, but I really can't remember. I have to look at it more carefully and see. So, if I plotted a point like right here, that point has an R value of 2 and a theta value of pi over 6. Now, what makes polar more complicated is that point right there that I plotted is 2 comma pi over 6. But couldn't that also be 2 comma negative 11 pi over 6? Would that be the same point? And in fact, would there be other ways I could gain that point besides those 2? Yeah, how about 13 pi over 6? Yeah, there's infinitely many. You can also change the sign on R. R can be negative, believe it or not. We'll talk about that in a minute. With all that in mind, let's look at example 1. Plot and label the following polar coordinates on the grid. All right, so he has labeled your special angles. And he wants you to plot 2 comma pi over 3. Can you do that? Easy. Call it A. Make sure you label it A. Put a point there and call it A. So you are on the second circle out. Watch your scale. The second circle out, which is not the second circle out. It's the one labeled 2. Watch your scale. So you're out there on that circle labeled 2 at pi over 3. All right, where's 1 comma 3 pi over 2? Straight down on the circle labeled 1. 3, 4 pi over 3. Can you find that one? Which quadrant is 4 pi over 3 in? In the third. And it will be on the pi over 3 line down there. In quadrant 3. And then 2 comma negative pi over 6. That's in quadrant 4, correct? Everybody okay with that? All right, let's look at example 2. 2 comma pi over 4, right here. There's 2 comma pi over 4. 2 comma negative 7 pi over 4. Where would that be? 2 negative 7 pi over 4. Same place? How about 2 comma 9 pi over 4? Same place? Negative 2, 5 pi over 4 is also in the same place. And here's why. When you change the sign on R, that means you're going the opposite direction. So, this is the same as a positive 2 pi over 4. Because the opposite direction is how many radians apart? What are these? How far apart are these? Pi. So if you have a negative R value, in order to plot the point, you have to change your angle by pi radians. Negative 2 means you're going the opposite direction of 5 pi over 4. What isn't this 5 pi over 4 right here? I need to go the opposite of it, so that puts me at pi over 4. So all 4 of the points in example 2 are plotted in exactly the same place. Exactly. All right, now you try it. Number 3, plot the point 3 comma 5 pi over 6. This is example 3. Plot 3 comma 5 pi over 6. Hopefully you're plotting it about like right here. Now name that point a couple of different ways. So the point 3 comma 5 pi over 6 can be renamed lots of different ways. Rename it this. Can you rename that point 2 different ways?
So if R is negative, is it just flip over the axis?
Yep.
Okay.
So if you want, oh, wait, it's a 3. If you want to do a negative R, he didn't stipulate what you were supposed to do. You could do a negative R. But what does a negative R do to your angle? Changes it by pi. So if I change this by pi, what is it going to become? 11 pi over 6, or negative pi over 6, would that be okay? Did anybody, that's 2 already, but did anybody think of another one? Is there another one you thought of?
3 17 pi over 6.
3, 17 pi over 6. How did you get 17 pi over 6? Added 2 pi. Anybody have a different one? 3, negative 7 pi over 6. So these guys left the radius positive. So what did they have to do to their angle? Since they left the radius positive, they added or subtracted 2 pi. The guys that changed the radius to be negative added and subtracted pi. That makes sense? That's how it's done. Okay. Now, example 4 says you're going to convert from polar to rectangular. You knew this was coming. You knew you're going to have to be able to change back and forth. And there are some really legitimate reasons why you need to be able to do that. So let's see if we can figure it out. without memorizing a bunch of stuff, let's see if we can figure out. So, the first one is 2 comma pi. What will 2 comma pi look like? Polar coordinates, 2 comma pi would be right here, wouldn't it? What do you think the rectangular coordinates are for that? The x comma y pair. What do you think that would be for that point right there? What? Not negative 1, 0. Negative 2, 0. Yeah, because we're 2 units out, so negative 2, 0. Well, that's easy. Let's try the next one. 4, 5 pi over 3. So 4, 5 pi over 3 would be over here. And your job, nice job yesterday, AJ.
Thank you.
4, 5 pi over 3, your job is to change that into an x and a y. Alright, so let's think about this for a second. If I were to make a triangle, I'm trying to find the x side and the y side of that triangle. Would you agree with that? Making it rectangular now. Horizontal, vertical. Any thoughts on how I could do that?
Multiply like the coordinates from the unit circle by 4.
Exactly. Exactly. Because you know that cosine equals x over r. You guys have known that since day 1, which means x is r cosine. If I just solve that. So what Bennett just said is, from the unit circle, you know what the cosine of 5 pi over 3 is. What's the cosine of 5 pi over 3? 1/2, positive 1/2, right, cosine? So if I times that by 4, then I'll have my x value. So what's my x value? 2. 4 cosine 5 pi over 3. All right, what's the sine of pi over 3? Because sine theta equals y over r, so y is going to be r sine. We know that already. What's the sine of 5 pi over 3? Negative radical 3 over 2. So I'm going to times that by 4. So 4 times negative root 3 over 2 will be negative 2 root 3. And there are your x and y. Nicely done, Bennett. So what do? We take our r, that's our unit circle value. Sine or cosine. X is cosine, y is sine. All right, do C. Do C. Remember, x is simply r cosine theta, and y is simply r sine theta. That's not never changed. You know that. X is r cosine, y is r sine. What's the cosine of 7 pi over 6? Negative root 3 over 2. So my x coordinate is going to be positive 3 root 3 over 2. What's the sine of 7 pi over 6? Negative 1/2. So this is going to be 3 halves, and there it is. Now, he cautions you, and I will caution caution you also, make sure when you write your answer, it makes sense. Look at our original point. Our original point was -3, 7 pi over 6. If I told you to plot that, which quadrant would that go in? Quadrant 1. This angle is in 3. But what does that radius do, that negative radius? Flips you to quadrant 1. Did your answer come out in quadrant 1? It surely did. It surely did. William?
Are we allowed to change the coordinates before we solve it?
Totally.
Okay.
You mean change it to 3 comma pi over 6? Absolutely get the same answer. You don't have to do that, but you absolutely can. All right. Cole, did you have a question?
I did.
All right. Now, let's look at example 5, because example 5 is the opposite. Example 5 says, here are your rectangular coordinates. Find your polar coordinates. So in other words, we are starting with -2, 2, and that's an x and a y, and we want to change that to an r and a theta. This is easy. This is super easy. -2, 2. If I plot that, would you agree it looks like this? Isn't this, I know I don't have it in a circle, but isn't this r right here? And I can find that. How will I find r? Pythagorean theorem. So that's going to be the square root of 8. So 2 radical 2. And then isn't this theta? Right? Now, these happen to be numbers that I know. I mean, not that I know them, but they're the same. And if the sides of, if these two x and y are the same, then I know the angle has to be how big? 1 of the pi over 4s. Isn't that where x and y match? And it happens to be the pi over 4 that is in quadrant 2, so that is 3 pi over 4. Now again, there are lots of ways you could write that answer, but I think for most normal people, that will be the way you get first, and then you can modify it if you want. Well, that was so easy. Let's try, you try this one. 1 -√3. And you're changing that into an r and a theta. And you find the r and the theta that go with that ordered pair.
What are we talking about? What are we talking about? Is that good news?
Give me a reading.
There, I think
Give me
it's
a
horrible.
reading.
news.
Give me a reading.
All right, you gotta finish this problem.
Sounds like a deal.
You're not going to, you have to go. Just stop it right now. Okay. What did you come up with?
Taco Bell, Taco Bell.
Nobody's going anywhere until we get done with our notes, so here we go.
Oh no, Mrs. Brown might dive into this math problem.
What did you come up with for x and y?
I got 2. And then 5 pi.
Wait, I need an r and a theta, so you got 2 and
5 pi.
5 pi over 3. All right, let's talk about that. Let's talk about that. So when I plot that point, 1 negative root 3, I think that's 2 if you do the Pythagorean theorem, right? Right? Now, you might not recognize the 1 in the root 3, but if we put it in the unit circle, you recognize the point 1/2 negative root 3 over 2, right? That is a pi over 3 angle. And since you're sitting in quadrant 4, you are correct. All right, how about the next one, which is 0, negative 5.
No, Miss O'Brien.
Stop it.
Yeah.
0, negative 5. Now those are x and y. Keep it straight. Those are x and y. So what's going to be the corresponding r and theta? Well, here it is. Yeah, it's all easy. What
Students, educators,
radius
thank you
is
so much for everyone's patience with us.
r
As
is?
you have probably seen your email on your text messages, due to the water
R
main break at the
is?
Indiana State Fairgrounds or near there, Cathedral will have to close for the day. We
What's
will
R?
begin staggered dismissal beginning at 11:25. Seniors will begin dismissing at 11:25. Juniors will begin dismissing at 11:30. However, if you have an underclassman that you are carpooling, you must wait for them. Please do not leave the underclassmen. Freshmen and sophomores, you will be dismissed shortly after the seniors and juniors. They will not leave you. Bus riders and any students being picked up should report to the dining hall while we coordinate those routes. As far as athletics, your practices should be scheduled, should be on as scheduled. However, please be sure to look for communication from your coaches in case anything has changed. We will come on for more information if it needs to be shared. Thank you and go Irish.
Okay, well, first of all, no cards for English are important right now.
I gotta
We
take a
are
call from one of
dismissing
these
for a
guys.
couple more minutes, so we're gonna talk about one more thing. Okay, stop it. You're missing a whole lesson here. We gotta get as much done as we can. You don't have to write this down, you've already packed up. But we're gonna talk about next time, changing complex numbers. So, like you have a number like 3 plus 2i, an imaginary number, a complex number. When we graph those in the Cartesian plane, the rectangular plane, we go over 3 and up 2. This is x and y. And then we draw a little vector like that. So that is the complex number 3 plus 2i. Now, because that's really just the point 3 comma 2, could I write that in polar form? Well, sure I could. All I need to know is this right here, that's r, and this right here, that is theta. Now, for the first time today, on this note, I need a calculator. Because 3 comma 2, do I know that on the unit circle? The radius is root 13. Do I have anything on my unit circle that looks like that? No. So what would I do? How would I find that angle? I could use those numbers, but it might be easier just to do second tangent 2/3. Inverse tangent 2/3. You could also do inverse cosine 3 over root 13 or sine 2 over root 13, but that's how you'll get the angle. All right, so we'll do that next time. That's when we'll start next time. Whoa, 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 whoa. What did she say?
It's a road.
She said seniors go at 20.
No, she said
No, she-
Wait, when you're 30, you get to go at 20.
Yeah, but Angel's dad's a cop.
So seniors go at
Scout's gonna be here.
seniors go 11:25.
Oh, junior.
30.
I need to check.
You can get your phones.